we have this Samsung Note 9 with power problem. If you take a look, it's already connected to my DC power supply, and if you take a look at my DC power supply, you will see that we have a current leakage right there. So we're going to talk about that. I've disconnected the cable. I'm going to reconnect the cable right here so that you will see that that's an auto current leakage, which is abnormal. Yeah, if you have gone through my courses or some of my current leakage troubleshooting videos here on YouTube, Facebook, TikTok, then you will know exactly that this is a current leakage, and you will also know where we have to start troubleshooting. If in case you don't know, I always try to make everything understandable, even to people who are still new to my channel, to my page. Everything will be good, so you will go through this, how you can troubleshoot current leakage fault. So as you can see, any auto current consumption that you get from your DC power supply, which is above 3 or above, there are some DC power supplies that will have an auto current reading even when something is not connected. I think that can be adjusted. Yeah, you can check on YouTube how to do that, but your DC power supply should be like mine. When there is nothing connected, you will see that when I disconnect it, it goes to 0, right? So when I reconnect it, you will see that auto current consumption. So anything above 10, let's say anything above 10, means that there is a current leakage that can actually stop the phone from powering on. So what happens when you press the power button? Press the power key. If you press the power key, you will see that there is nothing going on, right? So yeah, let's just go on then see how we can troubleshoot this fault. So to troubleshoot this, we open our schematic diagram software and we use our bit mapping. So the first thing, you have to locate the battery connector of this mobile PCB. If in case you are wondering which schematic diagram software we are using, I'm using Orion schematic diagram software here. You can use Orion, you can use Zen schematic, so you can use Bonio. All of them are great. So we use our schematic diagram and we locate, you can see the V battery, right? So this is the V bat. So we locate the V bat, we click on it and see where the V bat is connected to, because we want to find the charging IC, right? So you can see that it's connected to this IC. So we zoom in to the IC, we zoom into the IC, then we find the VPH line. So we have the VPH line right here. So what are we looking for? We're looking for the VPH because this is the first suspect when we are getting a current leakage from the VBAT line when we connect the phone to our DC power supply. As you can see, the phone is still connected. So we find this line. So we are opening this phone right now to test this inductor, to test all these components that are connected to this inductor right here. So this is the VBAT line. So we go straight and open the phone, locate this section, then we can test. As you can see, like I always say, keep in mind the VPH is the main power supply of this mobile PCB. The power manager IC takes in this VPH voltage. When you trigger the phone, the power manager IC decreases and distribute the voltage to different parts of the mobile PCB. So this is what happens when the VBAT is being converted to the VPH. That's why you see a lot of sections are using that VPH line, because it's the main power supply. It's even a standby power supply to most circuits in the mobile PCB. So yeah, just keep that in mind. That's very important when it comes to troubleshooting. So let's go on then, open this up and see how everything goes. Okay, great. If you take a look, you will see we have the VPH line here, and like I said, you can see what I was talking about. We have like a water corrosion here. So what we have to do, we set our multimeter to continuity test mode and check the VPH line. So you have to keep in mind that I said this is where you have to start troubleshooting this current leakage. Not in all cases that you will open and you will see that the VPH line is shorting, but that should be the first line where you should check when you are having such current leakage. So we perform a cold testing. The red probe goes to the ground and we use the black probe test the VPH inductor here. So that's a bit. So when you are testing this, you don't have to get a beep here because this is the VPH line and it should give a reading, not a beep. What we will have to do, you go to your bit mapping software. If you come here, you will see that if you click here, this is the side, like I said before, that is the side that distributes the voltage, the most part, and also to the power manager IC. So taking a look, you will see that we have a lot of sections here that are blinking red. So those are the lines that are connected directly to this line, which means that if you want to focus on these sections, to suspect any section here, it should be these ones that are blinking red here, because these are the ones that can be causing the short. If in case the short is not from this section, it can be from any other section that is blinking here. We have to inject that voltage here, so you will solder this here. So that's perfect. This is my DC power supply probes. You connect the black probe to the ground, then you connect the red probe to the wire that you just linked to the VPH inductor right here. So I will just connect this to the ground. So now that we have our rosin flux here, we have to go ahead and inject the voltage. So after connecting, you can see that high current consumption there. You can see there is nothing heating up here. And even when I try to take a good look at the PCB, everything seems to be okay. But yeah, that's okay. So even though there is a short here, the VPH is short in here, there is nothing heating up. So what I will do, I will disconnect this cable, spray this area again, because there are times that when you connect a cable and you inject current from that cable, so because of the shorting, the current leakage, the cable might heat up and cause the component that you solder the cable to heat up, and you might think that that's the main component that is shorting. So that's the reason why I disconnected this cable. I will then inject the voltage. We'll inject the voltage from here. So there are times that you will have to, we can even increase this to 4.5. That's okay for this line, that's okay. So we are doing this just because the component is not really heating up, and the reason why this inductor is heating up is because, yeah, it's because we are connecting this, we are injecting the voltage through the inductor, so the inductor should be okay. But this capacitor seems suspicious because you can see how it's heating up. It can be due to the solder that I just linked from the inductor to the capacitor. So we will go ahead and remove this capacitor just in case. it might be shorting or not, so we just have to remove that just to have a clear view while troubleshooting, not suspecting other ICs behind. I just disconnect the capacitor like this, and we use our multimeter again to check if that short is still there. We test this side, so that's still a short there. So it confirms that we just confirmed that the charging circuit here is okay. So the next circuit we will have to, because this PCB is not actually heating up, we have to locate the power manager section, because when it comes to this shorting fault, if you see that there is nothing heating up at all, if you locate the power manager section, you might see some capacitors in that section, little capacitors that are heating up, and they always heat up just a little bit. So that's the reason why we are locating this section. So if we go to our bit mapping, you will see that we have the power manager IC here. So these ICs around the power manager ICs are just smaller ICs, smaller capacitors here, and if they are shorting, in most cases they will heat up just a little bit, and if you don't remove the shield, spray the rosin flux, then inject the voltage to take a good look, you won't see. So we have to remove the shield. Okay, great. If you take a look, you will see that we have the power manager section here. We have the power manager IC, and let's do a quick test using our multimeter. Most of these capacitors here are supposed to be. So you can see these capacitors are shorting. So we use our rosin flux just like that, and we inject. We inject the voltage there, and take a look if there is anything heating up here even slowly. Okay, great. If you take a look at the other side here, you can see that there seems to be a capacitor here that is heating up. So just for us to confirm that, let's focus on that capacitor again. And because it's taking, we can put this to 4.5. That's actually okay. It's okay, and it's safe for this line. So let's inject the voltage again here. So you can see the current consumption from the DC power supply, and if you focus on this capacitor here, you can see that it's heating up, right? So this is what I was saying. Capacitors around the power manager section, in most cases they will heat up just a little bit. At times I increase the voltage to 5 volt to be able to see any capacitor heating up around these sections. I noticed this type of problem in most Pixel phones. So that capacitor is shorting, so let's remove this capacitor, hoping that this is the only problem. This is the only capacitor causing the short. So let's go ahead and remove this capacitor. Okay, that's the capacitor, just like that, and very smooth. So as you can see, this is where we are injecting the voltage. We injected the voltage from this capacitor and this, which means that if the short wasn't gone, we will be getting a short here, but we are getting 242 ohm reading right there. And also there is no short there. So let's turn to the VPH line. Even though if I was working this off camera, I would go straight to test, but I just want those of you who don't know much about the VPH or how connected these lines are to see that I'm actually going to test this VPH inductor here, and I won't get any reading from here, any short from here again. As you can see, we are getting the same reading there.